Hello, thank you. I want to show you a violation of the Liskov substitution principle. We have a post model, like just an active record model that can get published, and that just sets a flag. Maybe it does some other work, but I'm going to keep all of my examples very simple because I want to talk about the code and not some other stuff. And then we have, like later, we add a gallery post to inherit from post and add image galleries because, you know, the ad guys love that takes so many clicks and we can charge more money. And gallery post has a special publish because it has to email BuzzFeed to tell them to come and copy and paste the article to their site. And there's a bug here that's a violation of the Liskov substitution principle. The subclass doesn't remember to set the published flag to live up to the contract that the superclass has, and so some code down the line might get confused. The fix in this case is to call super and then do our special thing. There are still problems with this code, and trying to understand these led me to recognize that I was seeing bugs that were very similar to Liskov violations, but not actually Liskov violations. And before we can talk about all that, we've got to talk about this term, the Liskov substitution principle. So show of hands, and I'm not going to call on anyone, who feels they have a good understanding of what it is already? Half of the audience? Okay. And for those of you who do know what it is, do you know how many there are? Because there's a surprise. So this talk is the lessons of Liskov, and it has 4 parts. There's an intro where I'm going to talk about defining the Liskov substitution principle and give some examples. And then second, we're going to expand our view and explore some related concepts. Third, we're going to expand our definition of the Liskov substitution principle to recognize more potential bugs and write better code. And last, we're going to talk about how to do that. So I'm your speaker, Peter Bhat Harkins. I'm a Rails consultant from Chicago. I work for a company called DevMind, who have graciously helped me come out here to talk and practice Rails for years and years. I tweet as @pushcx, and I blog at valent.io, mostly about what principles are at work in real-world Ruby code, because I'm really interested in that intersection between like really abstract computer science-y stuff and actually putting a website up on the internet. And the last slide, which I'm going to leave up throughout Q&A, has a URL for downloading all the slides and my script, because I have a script because I get scared on stage. And so you can download everything if you want it later, so you don't even need to take a picture of the screen. There's one slide towards the end that's going to have like 5 links on it that you're going to want to take a picture of, but that one is just right on the page, so it's easy to get to. So part 1 is, what is the Liskov substitution principle, and what was that about there being multiple definitions? Well, it comes from this solid set of object-oriented principles for designing good code, and it showed up in the mid-90s, but first it showed up, I forgot my own slide. There are actually like 3 substitution principles when I went and I looked into it. So I'm also going to add a 4th to that just to make things a little more complicated. So the first one started in 1987, and there's this excerpt from a paper where she says the intuitive idea of a subtype is objects who provide all the behavior of another type, the supertype, plus something extra. Just like how we had that gallery post that has to provide all the things of a post plus something extra. This was coined by a woman named Barbara Liskov in this paper of hers in 1987. And it's getting at an intuitive idea that the use of that subclass shouldn't break our code, but it's really hard to formalize what shouldn't break means when allowing for useful changes. And despite all of her like math-sounding phrasing up here, it's just an informal aside in her paper. It's just 2 sentences that she doesn't she doesn't elaborate on it. She doesn't use it to evaluate design. She never even mentions it again in the paper. I don't think she was trying to create a principle for programmers to follow for writing good software for decades. I think she was just showing off a rule of thumb from a project she'd been finishing up. But 7 years later, she and a co-author named Jeanette Wing came back, and then they decided to formalize it, and they wrote this paper defining a subtype requirement for program safety. And it's like, there's 19 pages of really dense, abstract math defining what is computation, what is hierarchy, what are types, what does it mean to be correct. And it's really thorough and it's really dry, and I'm not going to go into all of it because this is not the Liskov substitution principle that we all know, because it was already too late. This is. There's a guy named Robert Uncle Bob Martin who coined the solid term, and I think he's the one who coined the Liskov substitution principle, although it's really hard to tell. He wrote about it on Usenet, in a magazine article that were both very popular, and then in a couple of books. And he was thinking about it through the lens of the C++ work that he was writing. That's why we see things like principal instead of requirement, class instead of type, and like a programmer user instead of like, let's do some math. So I'm going to stay with the popular convention. I'm going to keep calling it the Liskov substitution principle in this talk, or just the LSP. But I think it would be better named the Martin substitution principle, because like he made the one that we all know, and he popularized it, and it's really his work that I see. So let me touch back to that example we had. This is the buggy example before we fixed it. And it violates the Liskov substitution principle because it inherits from post, but its publish method doesn't do all of the work that the superclass one does. And this violation is why we care about the Liskov substitution in the first place. So is everybody on the right page? Do they understand this? Because now is a good time to wave at me and say if not, and I can answer any questions, because I'm happy to take questions in the talk, but if this part throws you, the whole talk's going to be not interesting to you. So I'm going to leave the violation here so we can talk about the three symptoms that I see over and over with code that violates the Liskov substitution principle. So here's an example bit of code. It's the simplest controller action in the world. It says, go get a post. Oh, but if it's not published yet, kick the user back out to the index of post. They don't get to look at it. And since we have that violation that never sets the published flag, we have to add a conditional. That's the first symptom I see of Liskov violations, is extra conditionals, especially the ones that use is a kind of respond to, where they have to like interrogate the object they're working with and see if it works for their principles. They have to check for the difference and then correct it or work around it somehow. In this case, we just say galleries are always visible. And I see Rails apps with all kinds of complicated code, especially with single table inheritance, like this, where single table inheritance is really fertile ground for LSP violations. And in this case, that conditional for dealing with the LSP violation is inside the class itself, where it says, oh, a gallery post doesn't actually have to have words, so it's okay if that field is blank. The second symptom I see a lot that shows up in this example of a little template, where we have to render text posts and galleries differently. So we turn the class name into the name of a partial, post or gallery underscore post.html.erb. And this second option is connaissance, which is kind of an obscure term. Jim Weirich did a couple of great talks about it. Specifically, this is connaissance of value. And connaissance just means that two pieces of code have to change together. So if we change gallery post to image post, we also have to remember to come and change the name of that partial, or we'll have a bug. There's kind of like a bug waiting to be written by someone who doesn't understand that these two things are coupled together and have to change together. And that possibility of a bug, that's our third option. So here's a scope for searching for posts. And it will never find any gallery posts because, as we saw earlier, they don't have a body. So this query wasn't updated to join against images and to check their captions or do some other useful thing. This third option of having a bug is really the most popular one in my experience. It sounds kind of snarky and mean, but it's because a lot of the times it's the right option if the circumstances mean we'll never trigger or care about the problem. If people aren't searching for galleries, nobody cares. But these bugs are hard because it's really easy to introduce them and then hard to recognize them. And in fact, that first code example, the one I fixed, that still had an LSP violation. So let's look back at it. I'm going to put them both on the same slide. We have the original superclass publish, and then we have the inherited one. And when I put them side by side, it's a little easier to see that the original publish returns what save does, which is going to be true or false based on whether it saves. And the second one is always going to return you an action mailer delivery job, which is not useful information. So the information of whether or not it's saved is just lost. It's an easy enough fix, but it's very easy to not realize what expectation we have to fulfill, that someone depends on this value. And everybody's probably looking at this and thinking about something, which is, well, actually, let me say, what do all of the Rails base classes have in common? Does anybody know this fun piece of trivia? Because they can't even agree on whether to use the word action or active. Yeah, they all have callback systems. Active model has its own, and then the others all reuse one common callback system. And that's really interesting to me, and I wondered, why is that? And so, shameless plug, I gave a talk last year at RailsConf that I think is about half of the answer, which is Rails doesn't give us any tools for controlling side effects, for saying when our models should be created or saved or deleted. And so if you want code to run when a post is saved, you have to connect to the existing save method, or someone is going to forget to call it. This is one of those things in Rails that's really convenient for prototypes and small systems, but just bites you in the ass in large systems. The other half of why I think all these things have callback systems is because it makes you, it saves you a lot of tedious boilerplate that you would have to write to avoid having a Liskov violation. In this case, like, this is what we want, is to only send the email if we saved successfully, except this is just really tedious code. Like, we'll never do something else with the Boolean. We'll never do something more, but we have to have exactly this code or we've introduced the bug again. And that kind of code you can only get wrong is a great thing to try and destroy. So if we rewrite it using the callbacks that are in active record, we get something that is much, much less bad. If we never override save in the first place, we never have that possibility for creating a violation, because the work that we want to add and the return value that somebody expects have been decoupled. That leads us into part 2 of the talk. What's going on in all this? Like, why is the Liskov substitution principle so easy to talk about and so easy to get wrong? And why do we mostly ignore it in Ruby, even when we're vulnerable to violations? Because it happens. When I find myself really puzzled, I like to explore how different systems deal with the problem. And I found myself looking at 5 different systems. The first thing was duck typing. It's one of the defining characteristics of Ruby. We say, if it looks like a duck, and it swims like a duck, and it quacks like a duck, it's probably a duck. The requirements for passing one object to another are totally ad hoc. There's no static typing, there's not even an interface listing required methods, and if there were, an object wouldn't have to implement it completely, just enough for what it happens to be used for. Rather than be coded up front, it might even use method missing or other metaprogramming to create itself at runtime from user data. And Alan Kay said one of the defining characteristics of object orientation is extreme late binding in all things, and you cannot get more extreme than, well, if the user doesn't happen to call this method, we never create 4 other methods. The downside of duck typing, though, is that we have no guarantees. For example, is my cat a boot? If you just need something about the right size and shape that likes to fit into shoeboxes, like, yeah, my cat's fine, but if you try and put your foot on her, you're going to get a really painful runtime exception. If we don't know what's expected from a duck, we might not find out, and we can fail to meet that criteria until our code has been like in production for a month and we see some unusual user data, and then we're like, oh, I forgot I had to do that. So the second thing I saw was interfaces, which are best described in Sandy Metz's really great book, Practical Object-Oriented Design in Ruby. And in chapter 6, she talks about how to create an abstract superclass to define the interfaces that subclasses are required to implement it. After working through the importance of depending on abstractions and some other really nice stuff, she then recommends a really nice pattern for Ruby, which is, say we have this abstract bicycle class that sets up an object, but it doesn't implement this method default tire size, because there really isn't a reasonable default for all bicycles. The subclasses, like recumbent bike, are required to implement default tire size, but Ruby doesn't provide a way for the superclass to say what it has to do. And since I just used subclass and superclass in the same sentence, you know somehow this is going to tie back into the Liskov substitution principle. And Sandy Metz's suggestion is to have the superclass explicitly warn about methods that the superclass must implement, like this: just name the method and raise not implemented error. It's really easy to find when we look at the superclass, and they give an informative error message if they're missed. But suppose we're writing recumbent bike and we see this, we don't actually know what we're supposed to do. Should we implement default tire size? Yeah, but what are we supposed to return? An integer? Is there a special tire size object we should be returning? Or maybe default is even a verb here, like I want you to set the default and we're supposed to update the tire size instance variable. Like, it's not obvious. We have to dig into the code more and more to understand. It's kind of like a danger sign that doesn't tell you what the danger is. Like, is there pollution? Is the building unsound? Is there a leopard? Like, is there a leopard behind me right now? What is the subclass supposed to be doing with this method? This is the sort of problem that static typing addresses. So that's the third system I want to look at. And I know that static typing to Ruby developers is a lot like crosses to vampires, but it has real values that we're trading off for flexibility, so we should understand what that trade-off is. In modern statically typed languages like C# and Java, the flexibility of polymorphism happens at compile time rather than at runtime. So here's the bicycle example again in C#. C# allows us to define exactly what the bicycle interface is. This line defining default tire size is a type signature. It says the function takes no arguments and it returns an integer. In Ruby, we don't have any kind of type signatures like this, but they really guide like what we're supposed to do. So when we implement recumbent bike, we know we have to tell the compiler that we meet this interface and return the proper thing. If we don't do that, the compiler will catch us and refuse to build the program. And then that kind of type error can be really frustrating, but it reminds me of the fourth system, which is what I always think of with type errors, and that's Haskell, which is really big on errors. The type signature for a function looks really different from C and Ruby, so I'm going to walk you through it one step at a time. On the left, we have maximum, because we're going to define a function named maximum to find the maximum element of a list. And second thing is we're saying the type has to be an instance of the ORD type class, which is a lot like saying that recumbent bike has to have the interface for bicycle. That word any there isn't a special word, it's just the variable that I happen to name here. So then the thing in the middle, the fat arrow, is not like Ruby's key to value thing. We're not making hash. It's just saying that this constraint applies to the next two arguments, which are it takes a list of any thing, and then it returns you one thing at the same time. So here's a simplified definition of the ORD type class. It's kind of a different phrasing from how C# does it. So it says that for a type to be orderable, there has to be a method named compare that takes two values and then returns an ordering. And an ordering is just one of these three values for less than, equal, or greater than. Again, it's an explicit way of saying that our type meets the interface, but now it's separate from the definition of the class. It's a system that's both very flexible and very strict. And in fact, when I first learned about ORD in Haskell, it struck a nerve with me, because as a Ruby developer, I recognized this. It recognized me of the fifth concept I want to talk about, which is Ruby's mix-in modules. So this is a couple screenshots from the enumerable documentation. We all know enumerable. And up top, there's the intro, and it's saying, yeah, if you give me this method called less than, equal, greater than, it's called the spaceship operator because it looks like a little UFO. If you make the spaceship operator to return one of these three values, you get things like sort and max, which is that exact same contract that you have in Haskell of you meet this interface and you return one of these values and you get this functionality. The big difference is that Haskell has a compiler that enforces it with really, really long error messages. But in Ruby, it's just sort of non-strict. Oh, that was a terrible joke about Haskell. That's okay. Anyway. So in Ruby mix-in modules, like you define one part and your object gets standard methods to be substitutable in more places. In Haskell, the ORD type class is this tiny, tiny little interface, just that one compare method. And in Ruby, it's part of enumerable, which requires you to implement each and the spaceship operator. And then suddenly you get, and I counted this morning, 53 more methods. Haskell is really all about composing like these little tiny abstractions, but Ruby is just like big and loose and flexible. And seeing the same thing expressed in two totally different ways from two totally different programming languages kind of shook something loose for me. It reminded me about what makes Ruby special. And that brings us to part 3, back to the Liskov substitution principle. I want to write some code that gets shot in the foot. It'll fail, but not because of an LSP violation and not because of something that was our fault. So here's the setup. We have that post again, and it belongs to an author. And then here's the innocent, unsuspecting code we're going to write to summarize a selection of posts. And it's going to take a collection, which can be an array or an active record query relation. It's not particular. And it says, oh, here's the title of the first one, and then how many others. So it might say, you know, come see my talk, and then, you know, and 4 more posts. And this could be used in an email or review, any place. Does anybody know enough Rails trivia to spot what this bug is? If there's an empty collection, yeah, it'll return -1. That's not even the bug I was thinking of, but that's a good one. Count will go to the database. Yeah, that's fine. I'm okay with that. It's actually even more annoying than all those things like empty collections or being slow on the first call. This is the exception you'll get out of it. Yeah, okay, I heard it back here. Both an array and an active record relation respond to count, and they say, oh, I have 23 posts. But a relation has this extra surprise where if the relation was grouped, it gives you back a hash instead, grouped by whatever you said. So in this case, like author 1 has written 8 posts and author 2, or I'm sorry, 5 posts and author 2 wrote 18 posts. And it sums to 23, but you get a hash instead of an integer. Our code really had no idea that relation could act differently. This is like just a gotcha. There isn't any inheritance at work to be an LSP violation either. A relation with or without a group clause is the same class, and even if it did, it doesn't have any inheritance hierarchy with array. There's nothing about honoring the class of a supertype here. So what does this mean for our code? We have those same 3 symptoms as an LSP violation. Either we have a conditional to check that the return type is an integer, or we have a connasance, a coupling to know that a group by relation will never get passed into this, or we have a bug. And this is what makes me want to broaden the Liskov substitution principle to give sort of a 4th definition. I want to talk about not inheritance. I want to talk about not the interface alone. I want to talk about substitutability. What is the contract expected out of this object? What does it mean for this class or method to be substitutable? This is kind of the core that all of those other 5 concepts are about. If it wasn't for the inconsistency in count, that summarize method doesn't care if it's given an array or a relation or any other object that happens to implement first and count. That's what summarize considers to be substitutable. We don't formalize an interface or a type class anyplace. There's no hierarchy. It's just these 2 methods. That's the core of what duck typing means. That is the heart of the duck. There was a good example in Rails earlier this week. When we use parameters in a controller, that object you get back is not a hash, even though it looks like one. It's this other class, action controller parameters, and it gets passed around to our app to view to other code that can work with parameters or hash, much like summarize can work with a list or an array or a relation. There's no inheritance at work. Parameters never inherits from hash, but they still had to add this dig method to match the new dig method that's on hash in Ruby 2.3. It's only a violation of this expanded concept of substitutability. It's not a violation of the Liskov substitution principle because, again, that's all about inheritance. The code using parameters expect it to quack like a hash, so it has to quack like a hash. Otherwise, that code would have to have a conditional to check for the difference, or a connasance, a value to know it was never passed one, or a bug. That's very familiar, those 3 symptoms. We don't care about the class or what it inherits from. We don't have to define the interface anywhere. We just start using objects. We rely on substitutability when we're open to receiving objects of a new type, and we honor our commitments to callers when we return objects that are substitutable for that particular use. This is what all those 5 systems were getting at. Duck typing is an extreme form of polymorphism that enforces no limits on your attempts to substitute values. Ruby interfaces allow us to code some of the basics of valid substitutions, and static interfaces include more of the rules of substitutability, like type. And then type classes include even more than interfaces can, more rules about substitutability that I could fit into this talk. And mix-in modules give similar benefits where our code meets their contract and then it becomes more substitutable in even more places. In Ruby, substitutability isn't about locking down some static type guarantee or saying that this method can only accept a hash and not a parameters, or it will only return a count, an int like that count method. Substitutability is about recognizing the interface that this code needs to work and then writing just the code needed to meet it. It's not about inheritance at all. It's about the role an object plays in our system. It's about every value we accept or return. Is it substitutable for any other valid value that the caller might be able to work with? We've been seeing substitutability over and over in these examples. It's here where a gallery post can't quite play the role of a text post because it doesn't have a body. And it's here where count returns really different objects. And a new example, it's here where we inherit from the standard library string, and then we have something ridiculous like, yeah, you can take a phone number and downcase it. String has 118 methods on it, so if we inherit from it, we're offering a huge interface to our callers, most of which doesn't make sense or can make data invalid. And it's here, it's everything wrong with nil. I hate nil. It's never the right thing to return, and it always causes problems. Every method that returns nil defies substitutability. It defies our efforts to write reliable programs. And yet nil is returned everywhere in Ruby on Rails, and the language does an incredible amount of work to sort of hide the fact that it can't be substitutable. Way up at the top of our inheritance hierarchy, we have this nil check, so that we can check everywhere. Are you nil? Are you nil? How about now? How about you? And then nil is the only thing besides the actual Boolean false that's falsy. It's a special case that's baked into the most basic conditional Ruby. And then also into the logical OR so that we can short circuit on it. And then there's this cutesy syntax for replacing a nil without the noise of explicitly checking for one. And then there's a method for digging through hashes without caring if data is missing. And when it sees nil, it returns more nils. And now it's in parameters. And there's a method for calling methods on a subject when we don't want to bother checking for nil, and we don't even care if we propagate nil onwards. And now in Ruby 2.3, we have kind of like the culmination of all of these. It's the combination of all of these, and they call it the safe navigation operator. And it propagates nil more efficiently than any of these others could. Because like now we know this is the opposite of safety. Nil is never substitutable for any value. Every time a method might return nil, you have to have a conditional to look for it, or a connasance, perhaps with one of many of these fine syntaxes, or you have a bug. And again, this is the most popular case by far for working with nil. And we see this bug all the time because we got a value that can never, ever substitute for any value that we work with. That's what it means for it to be nil. And that's also why the first draft of this talk had a different title. But now I understand why the guy who invented null called it a billion-dollar mistake. I mean, I yell about it because it's the unambiguous, unredeemable example of this problem of substitutability. So I want to take a breath and just relax a moment. Even if I'm angry at nil now, the world isn't on fire, but we have a new understanding of our code. We've defined substitutability. And it's a new tool for recognizing when code is going to go wrong. And I want to use it to improve our code. That's part 4 of the talk. It's fixes. How do we preserve substitutability? The simplest approach is to have multiple methods with different guarantees. Here's one way active record relation could be predictable. It could just preserve the existing behavior of count and then add another method to offer a broader contract. This is kind of the simplest to code, the simplest to understand, and I strongly recommend it. Like, I'm going to talk about other options, but you could use this exclusively and you could be happy. When we're dealing with errors, we could also just raise an exception instead of returning nil, and then we force people to deal with the possibility of an error. This works well, but it's kind of rough on the callers because exceptions aren't obvious without close reading of docs, and sometimes without even looking at the source and then being like, okay, what's every method you call and every method you call and what could you raise? I don't like to write code where I offer a method that could return nil because I don't like to write anything that returns nil. But if I'm given the option, I will always use something like find by bang to raise an exception so that I'm required to deal with nil at the point that the error is introduced, not like 5 layers down when some view partial starts throwing exceptions. It's just easier to diagnose these sort of things. And I don't have time to really explore them, but understanding maybe and either in Haskell and F# gave me a lot of the inspiration for this talk. So if we ask Ruby for like, what's the first element of an array, we get nil. And in Haskell, a function is not allowed to return nil. It has to return a maybe. It's a type that wraps up values. On the first line, we have the type signature, just like in C#, and it says, oh, we take a list of any type. And then the second line says, oh, if you give me an empty array, I give you nothing. But if you give me an array that I can break apart because it has things in it, I will give you just that first value of the array. Because it's in the type signature, the caller has to know this. It has to unpack that maybe and handle the nothing case, or it will not compile. And then the either type is just kind of a generalization of this that's mostly used for situations where you want to return a success or some specific list of errors. being forced to handle this possibility sounds like a giant pain in the ass, except that Haskell and F# have a lot of the conveniences and standards and idioms for dealing with this that we have for dealing with nil in Ruby. We see a little of these patterns in Ruby, though, too. If you think of making an HTTP request and getting back an API response object that might be a success response or an error response, this is that exact same pattern. Either way, you're getting back a valid piece of data rather than getting something that says, oh, you have to have a new control structure, you have to rescue something here, or you have to have a conditional here. And I think when we get data that encodes possibilities in something we have to special case like that, we get more reliable programs. And I think coding with like maybe and either as classes directly in Ruby will probably never be idiomatic thanks to a bunch of legacy code and how much special casing we already have around nil. But they were incredibly valuable for me to learn, and I think the time that you guys spend studying them will reward you with deeper insight into how to make reliable Ruby code. And so one more option for substitutability that we see fairly often is the null object pattern. And we have this kind of cross-cutting concern where we have, instead of a regular user object, an anonymous user object. And if you say, is the anonymous user allowed to visit this page? The answer is always no. It's really nice for this kind of broad cross-cutting concern, but otherwise it doesn't have a lot of use. I see it as having really limited utility because multiple methods are a lot easier, and you don't have to worry about a developer updating the real object and then forgetting to update the null object, in which case you are violating substitutability again. They're also limited by the fact that they can't use all of those fun nil special cases. It won't be considered nil in a conditional, or replaced by or equals, or removed by .compact in an array. And I would have thought that Ruby would be more duck-typed around this sort of thing, so that anything that returned true when asked, are you nil, would be handled as nil, but nil is just a special case. And you can't even inherit these behaviors by inheriting from nil class because of the way it's implemented as a singleton. You can't implement a second nil. And then the last thing about getting safer code is to get really suspicious when you see nil. Those conveniences are a trail that leads you back to where someone is violating substitutability and returning bad data. And then you can use all of these techniques, and again, my favorite one is multiple methods or maybe raising exceptions, and then just squash it at the source. So I have a couple of resources, and this is the slide that is just pasted right on the link at the end, so you don't have to try and grab these URLs now, of just really useful things for seeing more of the systems where anytime I said, I can't get into this, but, and I do have time for questions, but let me finish by summarizing kind of what we've been talking about the whole time. It's substitutability. The goal is a safe experience for callers where they don't have to fear no method error or worse, like a subtle difference between objects. We get there by encoding and using predictable interfaces, and we do that by providing and depending on small interfaces, so it's easy to do safe duck typing, because the real goal is to write good code and be happy. Thank you for your time and your attention.
Okay, so one question. Do you have any idea how to get more feedback, let's say feedback, for when we are writing Ruby code about our code is not safe here? As you have in Haskell, in Elm, for example, but yeah, they are statically typed. And
right. So
it's easier.
The question of how do we get more feedback? We're never going to get a compile time error out of Ruby, and that can be really frustrating if you're used to those things. But that's also kind of the deliberate beauty of Ruby is it wants to be ultimately flexible, so that at the very last moment at runtime, a method missing could step in and provide what we need. So it's really hard to make those kind of upfront guarantees. All we can do is look at the code and who uses it, and then try and be sure that when we provide things, provide a small interface, because then we know there's less work to do if we ever have to provide a substitute. So you had that phone number that had inherited from string, and it had 118 methods. If we ever make an on-campus phone number, where you know how some business campuses or universities, you only have to dial the last 5 or 6 digits. If we made another object, we're not going to write another 118 methods. We have no idea who's going to use them, though, so it's dangerous. So the smaller we keep our interfaces, the easier it is to write more reliable code.
How about making methods more strict by introducing some kind of it's called code contracts. You can, yeah. So you write one line above the method which specifies what arguments can be passed by. How about that solution?
Right. Should we add type signatures to Ruby, or do we want to have some kind of other contract explicitly? And there's a really good language for anybody who's interested in this called Eiffel that is mostly explored in a book called Object-Oriented Software Construction by Bertrand Meyer. And he talks about formalizing what are the preconditions and postconditions for every method. Like earlier, I wouldn't have had that extra bug if I had summarized would have said, oh, I have a precondition that the array you pass to me cannot be empty. Otherwise, the code won't run. And we can do a bit of this in Ruby with assertions and just write our own little assertion library that says something like, I assert that this is the case, or raise a runtime error. But doing that statically, again, is not Ruby's forte.
Okay, thank you.
First of all, thanks for the talk. It was my favorite so far.
Thank you.
When you spoke about enumerable and basically, oh, you need just need to implement a spaceship to get all the goodness of enumerable. And my first thought was, it's perfectly valid in Ruby to include enumerable and not provide a spaceship, and then you're kind of screwed. Would you think that it's not? It would be a good idea to just say include it and then check, like in your module, just to check if what you included makes sense.
So one thing that one thing that enumerable could do is enumerable could say, it could write a included method that fires when it gets included into a module, and then say, oh, do you respond to each, and do you respond to spaceship operator? I think that kind of safety is decent.
Except your app would not start if you do that, but that's fair game, I suppose.
Yeah, and I think an app that's not going to start when I run my test suite is much nicer than an app that might work for a while in production and then start failing.
So I wanted to ask you, do you use like something like maybe or either in your Ruby code?
No, I don't explicitly use it because it's so unusual to most Ruby code that even if it were technically correct, it would just be confusing and frustrating. But I do have that pattern of, well, if you call me and I might succeed and I might fail, I'll give you one object if you succeed and one object if you fail, but they both work together and they both provide the same interface, because then at least you get back data instead of a failure.
So, question about callbacks. You mentioned callbacks as a way of getting rid of these substitution problems. Do you consider callbacks a good approach in Ruby on Rails, or?
I think they are kind of handy at the controller level, but in models, I would like to never use them. Unfortunately, that's not possible because I can't say, oh, if you call post.save, well, you should either call save draft or you should call save to publish, and then I can do two different things. There's no way to enforce that. And if you do something like make save private, I've experimented with this, like all kinds of surprising things blow up. So because we expect all of our models to conform to this interface, we have to use callbacks in sometimes, but otherwise I would really rather never use them because they're sort of like the inverse of goto, where you don't, goto says, I want to jump to this other line of code. The inverse of that is called come from, and it's like, oh, whenever you reach that line of code, call me. And trying to find those and debug those is just kind of insane, especially because callbacks, especially on models, can be like hiding in other modules that get included or added at runtime. So I don't like the risk and the difficulty to debug them, but I do use them sometimes because that's just the world we live with. Thank you.